Hello, this is Sudha Malli, Assistant Professor, Department of Civil Engineering from Rohini College of Engineering and Technology, Kanyakumari. So, today we learn about the astronomical surveying. Astronomical means it's to study about the heavenly body, special for coordinate systems. The position of a heavenly body can be specified by two spherical coordinates, that is, by two angular distances measured along arcs of two great circles which cut each other at right angles. One of the great circles is known as the primary circle of the reference, and the other is secondary circle of reference. Coordinate system, the first method is there are three methods. First method is the horizon system, altitude and azimuth system. In this system, it is a plane of reference and coordinates of a heavenly body, or the first one is the azimuth and the altitude. This system is necessary by the fact that we can measure only horizontal and vertical angles with the engineer's transit. The true great circles of reference are the horizon and the observer's meridians, the former being the primary circle and the later and secondary circle. M is the heavenly body in the eastern part of the celestial sphere. Z is the observer's zenith and P is the celestial pole. Pass a vertical circle, that is the great circle through Z, through M to intersect the horizon plane at M dash. The first coordinate of M is then the azimuth capital A, which is angle between the observer's meridian and the vertical circle through the body. The azimuth can either be measured as the angular distance along the horizon measured from the meridian to the foot of the vertical circle through the point. It is also equal to the angle at the zenith between the meridian and the vertical circle through M. The other coordinate of M is altitude, that means alpha, which is the angular distance measured above or below the horizon, measured on the vertical circle through the body. Similarly, the position of M of the body is western part of the celestial sphere. It should be noted that in the northern hemisphere, the azimuth is always measured from a north, either eastward or westward, depending upon whether the body is in the eastern part of celestial sphere or in the western part of the celestial sphere. In the southern hemisphere, the azimuth is measured from the south to the east or the west. Alternatively, the position of a body is sometimes specified in terms of zenith distance and azimuth. The zenith distance of any body is its angular distance from zenith measured along the vertical circle. It is the complement of the altitude. Therefore, the formula of zenith distance is equal to 90 degree minus alpha. The horizon system of coordinates undergo constant and rapid changes due to the motions. Then second method, independent equatorial system, that is the in declination and right ascent system. So in this system, used to in the publication of star catalogs, almanacs of in which the position of heavenly bodies are referred to spherical coordinates which are independent of the observer's positions. The two great circles of reference, first one is equatorial circle and second one declination circle. The former being the primary circle and the later the secondary circle of reference. For fixed stars, this system of coordinates is independent of the place of observation and nearly independent of the time. The first coordinate of the body, M, is the right ascent, which is the angular distance along the arc of the celestial equator measured from the first point of Aries. It's a comma. As the point of reference towards east up to the declination circle passing through the body. It is also the angle measured eastward at the celestial pole. Between the hour angle through and the declination circle through M. The motion of the star is from east to west, and hence the right ascension is measured in the direction opposite to the motion of the heavenly body. It may be measured in degrees, minutes, and seconds of arc, or in hours, minutes, and seconds of time. The other coordinate in this system is in the declination, this del. It is the distance of the body from the equator measured along the arc of the declination circle. The declination circle is considered positive when the body is north of the equator and negative when it is in the south direction. The polar distance is the complement of the declination, that is the formula is P is equal to 90 degree minus del. The values of declination and right ascension of a fixed star in the heaven, although nearly constant, are not absolutely so. A register of these coordinates together with their annual change will enable to identify a star once observed. Such a register is called catalog of stars, and its correctness is of highest importance. The variation of the declination and right ascension of the sun is very much greater than for the stars. Then third one method is the dependent equatorial system and the declination and hour angle system. In this system, one coordinate is dependent of the observer's positions, and the other coordinate is the independent of the observer's positions. The two great circles of reference, first one is horizon, and the second one reference is the declination circle through the celestial body. So the first coordinate is the hour angle. In this system, hour angle is the angular distance along the arc of the horizon measured from the observer's meridian to the declination circle passing through the body. It is also measured as the angle subtended at the pole between the observer's meridian and the declination circle of the body. In the northern hemisphere, the hour angle is always measured from the south and towards west up to the declination circle. Its value varies from 0 degree to 360 degree. If H varies from 0 degree to 180 degree, the star is in the western hemisphere, otherwise in the eastern hemisphere. The plan on the plane of the equator illustrating how the hour angle is measured westward for two positions of the observer. The other coordinate is in the declination as in the second system. Okay, thank you.